Okay, so for these kinds of recurrence question, you guys need to write it in terms of what of the t value. So t means term, right? So you got term 1, term 2, term 3, term 4. Okay, and then the idea is that you need to write the next term in the order of based on the previous term, and then you can form a pattern after that. So let's say for question A, for example, t1 is 3, t2 is 6, and t3 is 9. Now let's see what the difference is. Well, if we write this one as 6 is 3 times 2, right, which is t1 times 2, let's see if this pattern will hold, right? So if term 2 is the first term times by 2, then term 3 is supposed to be the second term times by 2. So that would be 6 times 2, but that's not equals to 9. So it's not, the idea here is not times by 2. Okay, so of course, if you recognize straight away that term 2 is the same as term 1, which is 3, and then you plus another 3, right, then you will see that the pattern will apply. So this one would be 6 plus 3, right, based on the previous term, you see? So just plussing 3 to the previous term, so it'll be term 2 plus 3. That means that the current term, Tn, so remember this one is like the current term is then equals to the previous term, Tn minus 1. Tn minus 1 just means the number before this, right? It's like T2 is equals to T1 plus 3, right? So the current term is the previous term. So this is basically saying the previous term and then added by 3, okay? But then you need to specify what's the first term. Well, the first term T1 is equals to 3. So that's what it means by specifying a sequence. All right, so now for question 2b. Okay, so the same idea here. So term 1 equals to, the numbers are 1, 2, 4, 8. So 1, 2, 4, and 8. Okay, so the idea is that you write the next term, which is 2, that would be equals to the previous term, which is 1, and then times that by 2, right? Because if you add 1, it doesn't actually work. Plus 1 is not 4. So you can think of just add or plus, and that would be, term 2 would be 1 times 2, and term 3 would be 2 times 2, right? So the pattern here is times by 2. And the number is the previous term. If you can write it as a previous term straight away, it will, help you find the pattern even better. And then term 3 would be term 2, which is 2, and then you times that by 2, which is 4. All right, so then term 4 is 8, so it's the same as term 3 times by 2 again, which means that the current term, Tn, is equals to the previous term, and then times it by 2, where the first term is equals to 1. That's a pattern for question 2b. All right, about chapter 9a. So once again, this is chapter 9a. So chapter 9a, question 1d, based on Ashbridge's question. Again, the first term is -1, and then the current term is the previous term plus 2. So let's say so term 1 equals to -1. The current term, which is term 2, would be the previous term, which is term 1, and then you plus that by 2. So that will be -1 plus 2, which is 1. All right, and then term 3 is the previous term, which is term 2, and then plus that by 2. Right, so that would be the same thing. That would be, now term 2 was +1, so 1 plus 2 would be 3. So first 3 terms so far are -1, 1, and 3. It's just basically saying the current term is the previous term plus 2, and the starting term is -1. So you can see the pattern already. 1 plus 2 is 1, plus 2 is 3, and basically it'll just be all the odd numbers, and it will keep on going. All right, let's move on to chapter 4b. I will give you guys the explanation for these ones first, but I'll probably go through in the next lesson. Okay, so an arithmetic sequence, okay, an arithmetic sequence has the following rule: Tn equals to a plus n minus 1 times d. Okay, where a is the first term, right? This is the first term, or that's why some people like to write T1. Okay, so that's the first term, and D is the difference between them. Okay, so that means that, for example, in a rule where the first term, right? So first term equals to 3, and then the difference, right? The difference is 4, for example. That means that the pattern will be 3, and then plus 4 is 7, plus 4 is 11, plus 4 is 15, and so on and so forth. All right, so that's the idea here. Now, I'll go through an example of a harder question. Right, let's have a look at question 5 here. For an arithmetic sequence with the fourth term 7, I'll highlight the keywords. Fourth term is 7 and 30th term 85. Find A and D. Hence, find the 7th term, which is T7. So remember, the arithmetic sequence, you always need the A value and then the D value. All right, let's apply the rule. Fourth term is 7, so T4 is equals to 7. And remember, T4 means the fourth term, so the n there, right? The n here will correspond to the n in the formula. All right, so the fourth term means it will be the first term plus, and then fourth term, so that'll be 4 minus 1. So remember, the n in the t is the same as the n in the formula, right? These two values are the same. All right, and then times it by d. Okay, and then we've got the 30th term, so T30 is equals to 85. And that will be the same formula, but instead of having n equals to 4, the n here is 30. So that'll be 30 minus 1 times d. Now, these two form a simultaneous equation, and in order to solve them, you will need to take one equation, subtract another. So I'll rearrange it. a little bit, and actually first I'll simplify the top equation. All right, to simplify the top equation, I get 7 equals to A plus 3D. All right, and then the bottom one would be 85 equals to A plus 29D. Now note that this one I'll call that equation 1, and then this one I call that equation 2. All right. In order to solve this, I will need to try to get rid of one of the variables, and I would want to get rid of A. All right. How do I get rid of A? A is a term, which means that to get rid of it, we need to subtract. So I'll take equation 2, subtract equation 1. What does it mean by subtracting? Well, if you line them up in this way, right, and then 7 equals to A plus 3D. Note that when you subtract, you can subtract 85, subtract 7, and then A subtract A, and 29D subtract 3D. So then the A will just be 0, right? And then 29D subtract 3D is 26D. And then 85 subtract 7 is 78. Equals to 0. So 0 is just nothing, so I don't even need to write that. So 78 equals 26D, which means that you can divide both sides by 26, and that would give you, I believe, should be 3 equals to D. So the difference is 3. Now, how do we find A based on this? Well, if I substitute, well, if I sub D equals 3 into equation number 1, right, that equation there, right, into equation number 1, which is 7 equals to A plus 3D. But remember, we're substituting 3 into D, so that will be 3 times 3. And then you can solve for A from here. So 7 equals A plus 9. Subtract 9 on both sides. 7 minus 9 equals A. So negative 2 equals to A. So this arithmetic sequence is like saying, okay, the first term, so remember A is the first term, and then D is the difference, right? So the first term is negative 2, the difference is 3. So that would go negative 2, plus 3 is 1, plus 3 is 4, plus 3 is 7, and then 10, and then keep going. So that's why the fourth term, that we saw that, the fourth term is 7, right? 1, 2, 3, 4. That's the fourth term is 7. If you keep going, then you'll get the 30th term, which will be 85. Right, so that's how you solve this one. And then we need to find the 7th term. So we've got A and D, which means we get the formula Tn equals to, the first term is negative 2 plus n minus 1 times the difference, which is 3. So then we need to find the 7th term, so that's T7 equals to, and again, the n in the formula is the same as the n in the T. So T7 means the n here is 7. So that's 7 minus 1 times 3, and you just got to work it out. Negative 2 plus, that would be 6 times 3 is 18, so that would be 16, right? So therefore, T7 equals to 16. The 7th term is 16. Let's see if it's correct. All right, back to this sequence here. If we were to keep going, that's the 4th term, 5, 6, 7. Let's keep going. So 10 plus difference 3 is 13 and then 16. Aha, the seventh term is 16, so it's correct.